Good afternoon, everyone. Welcome to part 2 of the factoring polynomials notes. So this part 2 is really only one technique. It involves a very special trick that comes in handy just in general in algebra, especially as you go farther in your studies in math. So it involves this idea of making a substitution that is convenient. So when you solve a math problem, one thing to remember is as long as you follow all the basic rules like adding to both sides, subtracting to both sides, you're the boss when you solve a math problem. So consider this expression x to the fourth plus 12x squared plus 32. In this expression, I can define a new variable, which sounds hard, but it's really not so bad. So I don't know how to factor something that's x to the fourth plus 12x squared plus 32. I know how to factor things that are x squared plus something x plus a constant. So what we're going to do here is we're going to say this new variable is called u, and we're going to call it x. We're going to let u equal x squared. We use the letter u because you are awesome. No, we use the letter u because it just shows up. That's what they use in calculus. I don't know why. So if I let u equal x squared, then I can rewrite this expression as, so x to the fourth is x squared squared, right? And then plus 12x squared plus 32. And then substituting u in place of x squared gives me u squared plus 12u plus 32, which is something that I can factor. And u squared plus 12u plus 32 factors into u plus 4 times u plus 8. And then we could make the substitution back in. So since u is equal to x squared, then this would be x squared plus 4 times x squared plus 8. So we can use this to help us solve. So these first two, let's just write them in quadratic form if it's possible. In order for quadratic form to be possible, we need, first of all, the second exponent has to be half of the first exponent. So since n to the fourth is half of n to the eighth, not technically, like since 4 is half of 8, then we can write this one in quadratic form. So the other thing we notice is that 150 and 40, 150 is divisible by 25, which is 5 squared, and 40 is divisible by just 5. So we're going to let u equal 5n squared. Actually, we can let u equal 5n to the fourth, since we're starting with 8th power. So u equals 5n to the fourth. So then 150 is 6 times 5n to the fourth times 5n to the fourth squared. So 5 squared would be 25, and 25 times 6 is 150. Plus 8 times 5n to the fourth and then minus 15. So now when we make that substitution, we get that this is 6 times u squared plus 8u minus 15. And that's what we mean by write it in quadratic form. So number 2, this one we're not going to be able to write in quadratic form because this exponent of 3 is not half of 8. So this one's not possible. since 8 over 3 not 2. So we can use quadratic form to help us solve equations. So number 3 here, we have 18x to the 4th minus 21x squared plus 3 equals 0. So here we have 18. If I bring the 2 out, then 18 would be 2 times 3x squared squared. Then minus 7 times 3x squared plus 3. So the reason I noticed that there's a 3 is 18 is divisible by 3 squared and 21 is divisible by 3. So that's how I know that I'm going to have the 3x squared is going to be what I'm going to substitute for. So u is 3x squared. So I can rewrite this as 2u squared minus 7u plus 3, which is much easier to factor. So I need to find numbers that multiply to 6 and add to negative 7. So that's going to factor to 2u squared. So that's going to be minus u minus 6u plus 3. So factor out u, and we get 2u minus 1. Factor out negative 3, and we get 2u minus 1. So this factors to u minus 3 and 2u minus 1. So the solutions to this would be u equals 3 and 2u minus 1 equals 0, so that means u equals 1/2. But remember, we don't want to solve for u, we want to solve for what x is. So remember, we started with u is equal to 3x squared. So if u is equal to 3x squared, then 3x squared equals 3. Or 3x squared equals 1/2. And then we solve both of these equations, which are now much easier than our original equation. So this one I could divide by 3. We get x squared equals 1, which means that x is equal to plus or minus the square root of 1. So x equals plus or minus square root of 1 is just 1. So x equals positive or negative 1. The second one, same thing. We'll divide both sides by 3. So that gives us x squared equals, careful, so 1/2 divided by 3 is the same as multiplying 1/2 by 1/3. So that's x squared equals 1/6. X equals plus or minus the square root of 1/6. This square root of 1/6, usually that you'll see that written as, so we could first take the square root of the numerator and denominator separately. So 1 over the square root of 6. And here we use a trick that's called rationalizing the denominator. A long time ago, some old people decided that you can't have square roots in a denominator. So we multiply this by square root of 6 over square root of 6, which this is a number divided by itself, so it equals 1. And it's going to get rid of the square root in the denominator. So we're left with square root of 6 is our numerator, and the denominator is square root of 6 times square root of 6, which is 6. So these are the 4 solutions: plus or minus root 6 over 6 and plus or minus 1. So we'll do one more example. So think to yourself here for a second. what could possibly be the value that we can substitute here? So 10 and 8 are both divisible by 2, so that's important. And 8 is divisible by 2 squared. So it means we can rewrite this as 2x so 2x squared plus 5 times 2x squared minus 12 equals 0. So here we're letting our u equal 2x squared. So now this is just 2u squared plus 5u minus 12 equals 0. So now we need to find numbers that multiply to negative 24 and add to 5. So that's 2u squared plus 8u minus 3u minus 12. In the first two terms, we can factor out 2u, and we get 2u times u plus 4. Here we factor out negative 3 and get u plus 4. So the factors are 2u minus 3 and u plus 4. So solving for u would give us that u equals 3 over 2, or u equals negative 4. Remember, we don't want to solve for what u is. We want to solve for x. So since u is equal to x squared, or 2x squared, that means 2x squared equals 3 halves. So divide by 2 on both sides, which is the same as multiplying by a half on both sides. So x squared is 3/4. So then x is plus or minus the square root of 3/4. And since we can take the square root of numerator and denominator separately, that means it's plus or minus the square root of 3 over 2. Yes, Kitty, that's the answer. Now, for the second one, again, 2x squared equals negative 4. Divide both sides by 2 to get x squared equals negative 2. And then x equals plus or minus the square root of negative 2. And remember, to take the square root of a negative number, we have to use our imagination a little bit. So since there's a negative inside the square root, that means we bring the I out. So x equals plus or minus I times the square root of 2. And these are the 4 roots to this equation.